Yep. All right, guys, are there any questions on any of the homework assignments thus far? Anyone in particular? No? Yep. All right, guys. There was a question on number 10 for 4.1. This is the given equation. And the person said that f is a polynomial function, the degree is 4, and f is a quartic function. The leading coefficient is 2. Why would this be wrong?
Yeah. Yes, you're smart now.
Because of that, it's not a polynomial function. Because we can't have a radical in the equation and it be a polynomial function. Any other questions?
10 on 4.
Yep, this is 10 on 4.1. Were you asking for one? Okay.
10 on pump 3.
10 on pump 3. All right, guys. Let's look at the notes for today. So let's focus up here. Get off the Chromebooks. I didn't want you getting thrown out last night.
How about this?
So we have 4 different ways that we've gone over for solving polynomial equations, mainly for quadratics. The first way that we went over for solving these was by factoring. Because if I can rewrite a quadratic as a set of parentheses or 2 sets of parentheses, multiply together equals 0, well, one of them has to be 0. Now, the second way we went over solving was by graphing it. Because when we graph a polynomial function, whenever it crosses the x-axis, that would be a solution. Because we're looking for the values of x that will make the function equal 0. The method that we learned after that was the quadratic formula. And the quadratic formula is our x is equal to negative b plus or minus the square root of b squared minus 4 2a is our quadratic formula. And that's one of the ways that we learned how to solve these quadratics. And the last one was completing the square. And exactly, both of these here, 3 and 4, are really used for quadratics. They work very well for quadratics. Now, we could use it for some higher degree polynomial functions, but we have to rewrite it in a special way for it to work. So, really, if we can get it down to a quadratic, we can use the quadratic formula and solve. And that's really going to be the key to a lot of solving these higher degree polynomial functions. We want to try to find the zeros, or what values of x are the solutions of x, to decrease it down to at least a quadratic so that we can solve. Any questions on this here? Now, we're not going to solve really any of these too much by factoring, because we didn't have time and we don't have time to really delve into factoring before Christmas break. So what we can do is we can actually graph these polynomial functions to find the solutions. And looking at this here, what would you guys guess a value of x would be? Because we're trying to see where this is 0, right? What value would make all of these 0? Do we have any constant terms? Do we have any numbers without a variable?
No.
So if I plug 0 into 2x cubed, this is going to become 0, yes? If I plug it into negative 12x squared, it would be negative 18x.
0.
And if I add all those together, I get
0.
So if we have a higher degree polynomial equation that just has variables, we don't have a constant term, a number without a variable, we should expect one of the answers to be 0. Okay. Let's graph this. So follow along in the graphing calculator because this is going to be helpful. Now we do want to make sure that the function is equal to 0, which this first one is. And we can start off by typing it into the calculator. So we'd have 2x cubed, x to the third, minus 12x squared plus 18x. So we want to type this in. So for cubes or anything greater than 2, we can use what I call the little caret key, the button above the division key, to do powers. And whenever you do that, make sure to arrow over out of the exponent, because it's very easy to forget, and then type the rest of the equation up there in the exponent. Any questions on how we got this typed in? No? And then we hit graph. And we're looking for where the y value is 0, where it crosses the x-axis, yes? So we do have 1 at 0, 0, and then it looks like it's at 3. Now if we hit second graph, it will bring up a table. And where the y value is 0 is when x is 0, and when x is 3, yes? So let's go back over to the slides. So we did have x equal to 0, and we do have x is equal to 3. Now for this here, and we'll delve more into it when we talk about or get into 4.6, this one here will have 3 solutions. The degree and the number of solutions will always be the same. Well, how many solutions do we have? There you go. Plot 1 was turned on. Miss Shackelford gave it to me. Because we went over I this semester. Is I a real number? No. So pi is saying get. Pi is not rational because it has a non-repeating, non-terminating decimal. So I is saying. All right. So we got 0 and 3 as the two solutions, yes? Now for this here, the degree will be the same as the number of solutions. Well, what's the degree of this function? How many solutions should we have? So are we missing one? Yes. Now, one of the things that's interesting with synthetic division is that if the remainder is 0, then it's actually a solution for the numbers that we plug in. So I know with 0 and 3, I will get a remainder of 0. And I don't think I pointed this out yesterday, but each time we do synthetic division, we're decreasing the power by 1. So that means if I do this twice, I will decrease this power from 3 to 2 and from 2 to 1. And it'll be easier to solve for the last 0, whatever it is. So what we can start off by doing is plugging 0 in to the cubby hole, and across the top we would have 2, negative 12, 18, and then 0. Because since we don't have a constant term, we need to put 0 in its place. The next thing we need to do is drop down the 2. Then we would do 0 times 2 is negative 12 plus 0.
Wait, but aren't they all going to be zeros? That's 0.
And 0 times negative 12 is 18 plus 0 is 0 times 18 is, and 0 plus 0. And we expected the remainder to be 0, yes?
Yeah.
Because since it is a solution, the remainder will be 0. Now, we can do it again with our other solution. We drop down the 2 and do this again. 3 times 2 is? Negative 12 plus 6 is? And 3 times negative 6 is? 18 plus negative 18 is? So, do we have another number we can use?
No.
No, we had 2 that we found, yes?
Yep.
Let's plug the variables back in and see what we have. Well, this is our remainder. Negative 6 would be the constant term, and 2 is with x. So what we have left to solve is 2x minus 6 is equal to 0. So we can add 6 to both sides, which will tell us that 2x is equal to, and then we would, telling me that x is equal to, what were the other solutions we had? And so the 3 solutions are 3, 3, and 0. Now, I believe I talked about this when we talked about quadratics. I'm going to pull the graphing calculator back up. Whenever we have a part of the graph that comes down and touches the graph but does not cross it, we have an even multiplicity, which means there's an even number of zeros at that location. So here at 3, does it actually cross? Well, no. So that means there's an even number of zeros at that location. So it could be 2, it could be 4, 6. There's going to be an even number of them there. So it's a reason we could check it. But just having the 2 took this from a cubic function. We did it twice, and then we had a linear function. Well, we can solve linear functions. We like those, yes? I mean, that's better than a cubic. So we want to bring that power down. That's really what's behind solving these. I'm going to try to find as many solutions as I can, simplify it down as far as I can, and then go from there. Any questions on this here? The next one we have is this one here, 5x to the third minus 40x squared plus 80x. I'm going to do this a little bit differently than I did the first 2 hours. It's a happy birthday, so you don't have to use quadratic formula at least today. We're going to go on and graph this. Because in the first hours I used synthetic division and the quadratic formula, but we'll do it a little bit differently. But what do we know one of the values of x is going to be? 0. It is. It's right there next to the first one. So one of the values of x we expect it to be is 0, because do we have any constant terms? No. So we can come back over here and plug this in. So we would say 5x to the third, arrow over 1 to get out of the exponent, minus 40x squared plus 80x. And then we can hit graph. Now we can go second graph to look at the table. And we see it's 0. When x is 0, the y value is 0. And when x is 4, the y value is 0. So we do have 2 zeros at least. Now looking at this, the degree of the function is odd, yes? Because the degree is 3, so it's an odd function. And we looked at those odd functions. The end behavior said it was going to end up going in opposite directions, yes? Is this graph going in opposite directions? Yeah, because we have this one side where it crosses 0 going down. And after 4, it's going up. We're going in opposite directions, and it's the way that it's supposed to be, or way it should look. So most likely, there's not going to be any other place that's going to cross. So we can come back over here. So we have 0 and 4. And we can use synthetic division to simplify it down to figure out what the third number is. So the first one we can use is, well, 0. And we can bring down the 5. And 0 times 5 is 0. Negative 40 plus 0 is negative 40. 0 times negative 40 is 0. 80 plus 0 is 80. And 0 times 80 is 0. Then 0 plus 0 is 0. And that'd be our remainder. Any questions on this so far? Now we can do this again with 4. We can bring down the 5. Now 4 times 5 is 20. Negative 40 plus 20 is, and 4 times negative 20 is negative 80. And 80 plus negative 80 is Is there another number we want to try next? Is there a number that we could try? Okay. So we can go on and plug the numbers in. We can plug the variables back in, because 20 would be our constant term, and we would have is equal to. So here we can add 20 to both sides. Negative 20 plus 20. So 5x is equal to. We would divide it by. So x is equal to 4, 4, and that's it. Any other questions on this here? We ready for the next one? Finding the zeros is going to be the exact same thing as what we were just doing. Now we can find the zeros of this one here by actually factoring, but we're not going to worry about that here. We can actually go on and just graph it and do exactly what we were doing on the last one. Now we know one of the x's is not going to be 0 because, well, we do have a constant term. We have a number without a variable. So we can pull the graphing calculator up and hit y equals. We will clear this out. So we'll have negative 2x to the 4th plus 16x squared minus 32 is our function. And once we get it typed in, we can hit graph. And when we look at the graph, there are two places where it intersects or contacts the x-axis. And it looks like negative 2 and 2. Now if we do second graph, we can see that exactly at negative 2 and 2, it does intersect the graph, but it does not cross it. So we know that two of the solutions are negative 2 and 2. And we can use those to simplify this function down to hopefully find the rest. So we can try 2 first. Now across the top would be negative 2 for x to the 4th, and then we would follow it up with 0 for x to the 3rd, 16 for x squared, 0 for x, and then negative 32. And our first main step would bring down the negative 2. And then we'll do our multiplication. 2 times negative 2 is negative. 0 plus negative 4 is 2 times negative 4 is negative 8. 16 plus negative 8 is positive 8. 2 times 8 is 0 plus 16 is 16. 2 times 16 is, and negative 32 plus 32 is, any questions on this so far? What number do we want to use next? We bring down the negative 2. Negative 2 times negative 2 is 4. Negative 4 plus 4 is? Negative 2 times 0 is? 8 plus 0 is? Negative 2 times 8 is? Negative 16, which gives us? Is there another number we would want to try? Let's try 2 first. Yeah, let's see. Because if it gives us 0, it means it's a solution, yes? So 2 times negative 2 is negative. 0 plus negative 4 is? 2 times negative 4 is? And 8 plus negative 8 is? We do have one more solution. Which one do we think? Okay. We can try -2.
Oh, you're negative and you two's connected.
Yep. -2 times -2 is?
Positive 4.
-4 plus 4 is?
0.
Well, now we're just left with a constant term, so we're done. So x is equal to 2, 2, -2, and -2. So these here would be the 4 solutions. Any questions on this here? Now, if y'all didn't see to do that again, the 2 2's, what we could have done is at this point gone on and put the variables back in, because it would have been -2x squared plus 8. Because we could have stopped here when it was a quadratic and solved. Now, because there's not a middle term, we can use the square root method. We can get the x squared by itself, and then square root both sides. So what we could have done is subtracted 8 from both sides, which these here would have canceled, leaving me with -2x squared is equal to -8. Well, almost, because we need to get x squared completely by itself. That -2 out front, we need to divide both sides by the -2. Because -2x squared divided by -2, these will cancel, leaving me with just x squared. -8 divided by -2 is 4. And if we square root both sides now, square root of x squared is x is equal to plus or minus 2. So it's another way to get to those 2 answers. Questions on this here?
What do you feel?
Let's look at the next one. We'll look at this one and one more, and then we will be done for today. So we look at this one here, we have f of x equals x to the 4th minus 18x squared plus 81. So we're
Oh gosh.
So the first thing we can do is plug this into the calculator to get as many zeros as possible. We can clear this out and say x to the 4th minus 18x squared plus 81. So we can do the caret key and then 4, because the caret key will actually put us up into the exponent. Yep. And we can go on and hit graph. We see there is 2 possible places where there is a 0, and it looks like it's at -3 and 3. So we can go second graph to give us a table to see what those values are. And it does confirm that at -3 and 3, the y value is 0. So those are solutions for this function. So we pull this up here, we can say x is equal to 3 and -3 for sure. And then we can do our synthetic division to find the others. Now we would have 1 for x to the 4th, 0 for x cubed, for x squared, and the first thing we're going to do is drop the 1. We're going to do 3 times 1, which is 0 plus 3 is 3. 3 times 3 is 9. Negative 18 plus 9 is negative 9. 3 times negative 9 is negative 27. 0 plus negative 27 is negative 27. And 3 times negative 27 is negative 81. And 81 plus negative 81 is 0. Now at this point here, we can plug in and do this again with negative 3. We can bring down the 1. Negative 3 times 1 is negative 3. 3 plus negative 3 is? Negative 3 times 0 is? Negative 9 plus 0 is? Negative 9. And negative 3 times negative 9 is? And negative 27 plus 27 is? So we brought it all the way down to a quadratic, because we took it from a degree 4 to a degree 3, and from a degree 3 to a degree 2. So we can go on and put the variables back in. This 0 would be our remainder. The negative 9 would be the constant term. 0 would be the term with x, and 1 would be the term with x squared. So what we're left with is x squared minus 9 is equal to 0. Now at this point here, we can solve for the value of x by using the quadratic formula, or we can actually use the square root method, because the only variable that we have is x squared. So we can get it by itself. So how can we get it by itself? We can add 9 to both sides. And if I add 9 to both sides, I will get that x squared is equal to 9. And then what can we do? Square root both sides. And when I square, x is equal to plus or minus 3. But we also had another positive negative 3 already, because it gave us plus and minus 3, positive negative 3 from the graph, and it worked out that the other two solutions were actually also positive or negative 3. Any other questions on this here? Yes. Any other questions on anything we've done so far today? We'll stop here for today.